This video follows on from the last one in the playlist that showed us how to display the current time in a Python tkinter window. What we're going to do in this video is to show how we can alter the program we previously looked at in the last video to ensure that we have a current time displayed every second. In other words, a clock. And we're going to be looking at a digital clock. I'm going to quickly consider the program we looked at in the previous video, and here you can see that I'm importing the tkinter and the time module. Here we're creating an instance of the window. This is setting the title of that window to current time, and this line is the one we considered in some detail in the previous video, and it is responsible for obtaining the current time and creating a string in a format dictated by this string here. This is a method that's invoked, and to this method we pass this string, and what will happen is this method will obtain a time by reading the clock, and it'll have in this position here the hours. It'll then put in the colon, it'll then get the minutes, it'll then put in a colon, it'll then get the seconds, and this then creates a string, and this is the name bound to that instance of the string returned from this method. Now, if that description of this line was a little too quick, I recommend you go back to the previous video in the playlist where we considered this in a lot more detail. This line then created a label, an instance of a label that's associated with this window that was created on this line. The font of this label is going to be set to Arial 80. The background color is going to be black. The foreground color is going to be red. And the label is going to have in its text property the value of the current time that was returned on this line, and then this will put the label at row 0 and column 0, and what we will typically see at the output is the following: 9 hours 37 minutes 34 seconds, and then we enter the main loop. Now what's happening now is the program is going round this main loop, and as a user I could click here to minimize the current time, I could click here to maximize this window, or I could click here and shut the window down. But we can see that when this program executed, it executed each of the program statements in turn, as you can see by the animation that's taking place now. This executes, then this, then this, then this, then this, and then we entered this loop here. And of course it would appear that nothing is executing now, but of course what this has done is set up what's called an event loop. That means it's waiting for the user of your program to do something. And of course what we can do as the user is to click onto one of these and have the effect that we've just described, either maximizing, minimizing, or shutting the window down. Now, this computer program has amended the one we've just seen, and this program does not read the current time. And I've done this because I want to see the output that we get for this computer program before I build on it to show how we can derive the digital clock. Well, the first thing to say here is that we create an instance of the window. What this will do, it'll set the title of that window to digital clock. So you can see I've changed this string here to reflect that what we're trying to build here is a digital clock. This will create a label that is bound to this window, which we created on this line. The font you can see is Arial 80. The background color is black. The foreground color of the text is going to be red. But if you remember, in this position, I had text equals the current time. Now I've removed that. Now here what I do, I put the label that's created here in row 0, column 0, and then I go into the main event loop. So if I look at this program when it executes, we will see the following. And there's no current time there because I've not read it and I've not attempted to display it. But what you can see here is a black line. Now that is actually the label, and it's this height because we have got the font being rather big. So it's saying, well, I'm the right height to receive an Arial size 80 font. But it doesn't go in this direction, it's thin, because there has been no attempt to assign any text to it. Now if I drag this window to a bigger size, as you can see here, we can look in this area and you can see that says digital clock, and that's because of this line here where we set the title of the window to digital clock. as the user of this computer program, I was able to drag this window to a bigger size because the setup of the window is such that that's one of the things you can do to it. It comes with every window that you create in the same way as clicking on these will perform some kind of task. But the key I want to emphasize here is this event was captured because we're in this main loop here. We're in the event loop. And essentially, when we're in the event loop, the window is listening for events that might take place, such as dragging the window to a different size. So we get a lot of code behind the scenes that allows us to do this kind of thing. Now, I've taken the program that I've just described, which are these 4 lines here being exactly the same as the one we've just discussed, but I've included this here immediately after those 4 lines. And this is going to be a call to a function which I've typed in here. So when this program executes, we execute this, which creates the window. This sets the title of that window to digital clock. This here creates a label that it will have nothing in because I've not set the text property. And here we position that label onto the window at row 0, column 0. This then calls this function, and this is the first line to execute. And this will go and get the current time formatted appropriately as a string. And this then will be the name bound to that string, where that string is the current time. If we look at this, what this is doing, it's referring to the label that was created on this line, and it's saying change its text property, which currently has nothing in. And if you remember, when it had nothing in, we just had that black line appear on the window, and we're going to assign to it this, which is the string, because this is bound to the string that holds the current time. So we should see the current time displayed in the label that's on the window. And then, of course, we return from this function to this line where we enter the main loop. So when we run the program, we will see this output. And we've got the current time. And this is supposed to be a digital clock. But what's happened, it's just given us the current time. It's not counting up in seconds as we would expect. Now, the reason for that is I have just displayed the current time. And once I get to here, I'm in the main loop. And this window is, because it's in the event loop, listening for events. It's waiting for me to do something, make the window bigger, make it smaller, minimize it, maximize it, shut it down. In other words, it's able to respond to events because it is a tkinter window, and these come with this window, the ability to respond to events. But if I want this to display the current time, I'm going to have to execute this again. But of course I can't, because I executed it here, and now I've entered the main loop, and I've no way of getting back in my code to execute this. Because if you remember, the execution of the program code can be shown by the following animation. This executes, then this, then this, then this, then this, which takes us to execute this line, then this line, and then we return to this main loop here. So we can no longer get back to here to execute any of this, because we're now in the main loop. So all this computer program has done is read the current time and displayed it, and that's it. It can't go and read the current time again to read a new current time and display that. If I wanted to see a new time, I'd have to shut this down and run the program again, and it would just give me the current time. Now, it only needs a minor modification, this program. In fact, it only needs one more line to turn it into a digital clock, and that's what the next slide is going to look at. Now, this is the computer program we've just been considering, with the addition of this one line here, which is my underscore window, full stop, after, and here we can see we've got 1000, and here we can see we have display time, which is the name of this function, as you can see here, that this line appears in. Now, this line is a message to this window that was created on this line that causes this method here to execute the after method. And we pass into the method this 1000 and this, which is the name of this function. Now, when you invoke this method, what will happen is Python will set off a clock counting down, and it'll count down from this number, where this number represents 1000 milliseconds. So whatever number you put here is the number of milliseconds that you have. And because this is 1000, it's 1000 milliseconds, which we know is a second. In effect, invoking this method has arranged for this window to respond not only to us clicking on to maximize and minimize the window and shut it down, but it's also now allowing it to listen for when the 1000 milliseconds counts down to 0. And as soon as it counts down to 0, the window will detect it as an event. And it will then say, right, well, an event's just occurred, and I'm going to therefore execute this. So it executes this, which is this. This, therefore, the first line within the method to execute, gets the current time. This line then puts the current time to the label for it to be displayed. And then we execute this. And this starts off the clock again, counting down from 1000 milliseconds. We leave this function, and then we go here into the main loop. While we're going round this main loop, the window will be displayed, and the window will respond to user events such as me clicking on the maximize, the minimize, and so on, making the window bigger, dragging it bigger. But we also now have another kind of event set up by this, which is a system event. Nothing to do with the user now. In the background, we have this clock counting down from 1000 milliseconds, and when it gets to 0, an event is raised, which has nothing to do with me as the user of the software, of the program. It's the system, it's Python controlling the reduction of a timer, and will fire an event, and the window is there listening for that event. Why the window? Because look, I'm referring to the window here, and after the 1000 milliseconds period of time, i.e. the 1 second, it knows because of this line that it's to execute this, which is this function. So it goes to this line, gets the current time, displays it, and then fires this off again. And the process repeats. So let's then do a walk through this computer program. This is the first line to execute in the program. This creates a window. This sets the title of the window to digital clock. This creates a label with no text in it. This places the label within the window. This then calls this function. This is the first line of the function to execute, which gets the current time. This line puts the current time to the text property of the label, displaying the current time. And if we have a look at what the current time will look like now in the clock, it'll look like this as an example. Then of course this will execute, and this sets a clock going in the background. We now carry on knowing that clock's in the background, and we come to here, and we're in the main loop. And now this window will respond to user events, i.e. me clicking on any of these to maximize it, minimize, and shut it down. But it'll also now respond to an event that this has set up, and that event is when this comes down from 1000 to 0, the event will take place, and then this will execute again, because you can see from this line it's saying after 1000 milliseconds execute this. But bear in mind, we're not in this function when this 1000 milliseconds completes. We're in here, we're in the main loop. It's just now that this window can respond to the event that is raised. So now what will happen? We'll execute this again, and this will get the new current time, and then we will output the new current time to the label. So if you keep your eye on this position, that goes up to 6. Then what happens? We come to this and we fire the clock off again in the background, and then of course we return to the main loop. And while we're in the main loop, as a user I can click on any of these and it'll perform the task. And if I just don't do anything, I know 1 second later what's going to happen. The window is going to respond to an event, and because of this line, the event will call this method, which is this method. This will read the current time. It'll then display the current time. So if you keep your eye on the digital clock, you can see that this 6 here will change to the 7, and of course this then will fire off the clock again, counting down from 1000 1000 milliseconds. And when we then set that off running, we leave this function and we go to here, back into the main loop. So we have a mechanism now shown here that will set a clock running, and when the clock gets down to 0, it'll fire an event off that will tell this window, you better take note of this event, and the note I want you to take is to execute this method, which is the name of this method here. Now I would like to emphasize the following point. If we consider the execution of the program, we know this will execute, then this, then this, then this, then this. And it's important to note, with respect to this line, it only executes the once. This call only executes the once. And the first time it executes this, which gets the current time, puts the current time out, and then it fires off this. We never get back to this position in the program again. We transfer our execution to the main event loop when this method executes the first time. We have no mechanism of getting back to execute this call again. The call is set up because of this line here saying after 100 milliseconds execute this, which is the name of this function. So these lines here that you see all execute the once, and then we're in the main event loop and we continually call this function here, and this is the function that keeps on updating the time, but this is called from within the event loop. Now I would like us to look at this line again and see here that I'm passing in 1000, which means we're going to have the clock counting down from 1 second down to 0. Now that's fine, it works, and if you run the program you can see the seconds counting up, and of course as it counts up the minutes will then change, and if you leave it running long enough the hour will also change. But having this at 1000, i.e. 1 second, is not a sensible thing to do. I'm not going to go into the details as to why at the moment, but there is a chance that it might miss one of the seconds, because remember this will take some time to execute, so at one point in the future you might miss the time. In other words, you'll read the time and it's gone on to the next second and it's missed the current second that you should have been displaying by maybe 1 millisecond. Well, that's long enough for it to jump up to the wrong second. So what you can do, you can reduce this number, and it is usual to have this updating every 200 milliseconds. Now it means that when this executes it might be reading the same time, because if you have this as 200 milliseconds then it's highly likely that this will execute 5 times in a second, which means that this will read the same time 5 times in a second, but it won't have much effect on the display. We won't realize that's going on behind the scenes. So I'm going to alter this program on the next slide, as you can see here, and you can see I've made it 200 milliseconds, and the program will work in exactly the same way. It'll just update the text property of the label more frequently, and sometimes when it updates it there'll be no change in the time, but then of course it will show a change in the time eventually, i.e. every second. Consider this computer program and the runtime. If you look to the runtime you can see it's a clock, because you can see the seconds changing, and eventually we'll get to the point where the minutes will change, leave it running long enough and the hours will change. But you can also see that we have here PM telling us that this is 3 o'clock in the afternoon and so many minutes and so many seconds. Now the program that's done this is this one here, and it's identical to the program we looked at on the last slide with this change here. I'm just passing in a different string, a different formatting string, and what this will do is give us a 12-hour clock that'll put here either PM as you can see it now, or AM if we were dealing with times in the morning, for example. I've made another alteration to the computer program, and that alteration is reflecting itself in the runtime. Keep an eye on the runtime for a moment and you will see that the seconds are changing, but have a look how they're changing. They're going up in 5 seconds at a time. Just watch it for a moment. Now you can see that it was going up in 5 seconds at a time, and the reason for this is if you come here and have a look at what I'm doing on this line, I'm passing in 5,000 here. Now that's 5,000 milliseconds, which means it's 5 seconds. So this function will now only execute every 5 seconds, and of course it's this function that updates the label. So I've just shown you this to illustrate the purpose of this here. We can see we've had it at 1000, we've had it at 200, and you can see what happens when you have it at 5000. Of course, for the digital clock, you would most probably wanting it going up in seconds, so you would keep this here at 200, not 5000 as this is showing. Check out the supporting website for these videos. In addition, why not follow me on Twitter, as I issue a tweet every time I upload a new video.